Can everyone in the room can hear me loud and clear? Excellent. I love you. Thank you all for being on time. I'm going to go ahead and get started. If more people come in, that's fine. We'll be able to catch them up. It's an honor for me to be the first talk in the main track of the UTW this year. I was on the committee that organized the first Unicode technology workshop in 2023, and it's really, really great to be back here again this year on this beautiful stage at this beautiful venue. Thank you, Microsoft, for hosting us here. This is me. My name is Shane Carr. I'm convener of the ECMA TC39TG2, as well as chair of the Unicode ICU4X technical committee, which you'll be learning a lot more about in the talk here. The first thing there is my work on the JavaScript standard and the internationalization in JavaScript. I work on internationalization engineering at Google, but this talk is on behalf of Google. It's on behalf of my work in Unicode. So let's first answer a question that I think a lot of the people in this room might have, which is, what is ICU4X? If you already know what ICU4X is, great. If you don't, I'm going to go ahead and give you just a little bit of an intro about what is ICU4X. If you're at the tutorial session yesterday that my colleague Zebi gave, you might recognize some of this material from there. But that's OK, because I'm going to start over again. So internationalization is I followed by 18 letters followed by N. You're at a Unicode-related conference event. Hopefully this is not new to you, but if it is, this is where the acronym comes from. What is internationalization? I love this slide. These are two screenshots from YouTube. On the left side is YouTube when I set my locale to Japanese. On the right is when I set my locale to Spanish. And you can see how some of the things on the screen change, right? So for example, down here on the left, it shows some dates as well as some numbers. Also some numbers in the terms of the number of upvotes. How many upvotes does this video have? Does anyone know how many, when I took this screenshot, how many thumbs ups this video has? On the left, it's like 191 somethings, but on the right, it's like 1,9 somethings. And because the way that you display large numbers is not always in terms of powers of 10 to the 3. In the case of Japanese, it's powers of 10 to the 4 and things like this. So the way that you just display large numbers change. A lot of people don't really think about that. The way, of course, you display dates change. And our job as internationalization engineers is to make this seamless, so you don't have to think about it, because the people who have to think about it are the people writing the internationalization libraries, the people working in Unicode, the people who put these libraries in the CLDR together. So let's talk about some more examples of problems that internationalization libraries solve. Locale manipulation. This is a way that you can have a particular language, and not just a language and a region, but also attributes associated with that. So for example, if you prefer to use metric units, but you're speaking US English, right? You might want to be able to express that into your locale string. Another example is number, currency, and unit formatting. I'm sure that this is something that a lot of people think about. Currencies and dates are sort of two of the big things that people think about when they think about internationalization, but there's really so much more than that. Date and time zone formatting. Time zone is one that a lot of people don't really think about, that actually it's internationalization that solves this problem. Because when new countries add time zones, for example, when the minister in Chile says, my region in Chile is getting a new time zone effective next week. Have you ever thought about the effort that it takes for engineers to deploy that to all devices worldwide within 7 days to make sure that people start getting the correct time after the time zone changes in that way? It's our team that does that. It's an internationalization problem. Number and date range formatting. Which is a subset of date formatting. Relative time formatting is another sort of problem in that category. This is interesting, especially when you start to get to things like 1 day ago, 2 days ago, which have words in some languages but not in other languages. You have to think a lot about inflections. I see some people from the inflections working group here who know a lot about that problem space. Temporal. I work a lot of the JavaScript standard, as I mentioned earlier, and dealing with non-Gregorian calendars is a really big part of what we do, thinking about how you can do calculations on those dates. Collation is how you do alphabetical sorting of strings, which of course varies between languages, because this condition I have here is true in Danish, but it might not be true in other languages. Plural rules is how you can select the correct form of a string if you're formatting a message to a user. List formatting is also about formatting messages to users. Display names, if you've ever tried to go into your phone and select a language, select a region, there's a drop-down menu that has to be localized for you. text segmentation. I have a talk later today about text segmentation, so I'm not going to talk about it too much here, but I encourage you to come back again later. The talk is called No Spaces, No Problem. I'm going to be talking about text segmentation later today. So this is just an example of some of the problems that are in the internationalization space that a lot of people just don't think about. And you need to have a library to do these things, because these things just don't come for free. So something down there has to figure out how to do these things. So when we think about existing internationalization libraries, there's ICU4C, ICU4J. They're venerable. They've been around for over 20 years, and they do a great job at solving these problems. There's some costs to them, and some problems that they don't solve as well as they could. One is paying for what you use. So this is one of my favorite graphs here. This is a three-dimensional chart. On the x-axis, we have locales. So every column is a new locale that CLDR supports. On the y-axis is coverage, so features. Every row is some feature that CLDR covers, and the z-axis is the CLDR release number. So what you read from this graph is every CLDR release number, CLDR supports more locales and more languages, and it means that you have like a quadratic growth of data. And what this means is that languages like ICU4C that ship all of the data in one, which is great for certain use cases, has worked since the 1990s, don't scale in the way that we would like them to scale. So the second way that the second goal we have in an internationalization library is to add extra locales on demand. So what this means is being able to add like long tail languages. You see that there's a lot of languages in CLDR that have like what we call basic coverage. And we would like to be able to support those languages, but when we do that, we don't want to make all customers pay cost for that. Supporting on all different types of devices, including constrained environments, and writing once and running in many different programming languages. These are technical considerations, so when people come and want to solve an internationalization problem, ICU4C and ICU4J, they're great libraries. They don't solve these problems. They weren't designed to solve these problems. They were designed at a time when these weren't the problems that we had at that time. So this is where ICU4X comes in. So the ICU4X Technical Committee in 2019, 3 companies got together and decided we're going to try to solve this problem. Mozilla, Google, and Amazon, we got together and formed a new what at the time was a subcommittee, now is a technical committee in Unicode, called the ICU4X Technical Committee. This is a little bit of the journey. So in 2019, we identified our problems. We identified the solutions. In 2020, we started work on the project. 2022 was our first release of the ICU4X project. In 2023, we landed it in our first major clients. We landed in Firefox. We landed on Pixel Watch. If you've used Firefox or Pixel Watch, you've used ICU4X. This year in 2025, we launched our next we launched the next version of our library, and we are landing in Android and Chrome, which is the title of this talk. I'll have a whole bunch of slides later to talk about how we are able to solve problems for Android and Chrome. It's also our 5th birthday. The 5th birthday was in May. We incorporated it in April or May. So we've been around for 5 years now. We're used in production. We're used by once Android and Chrome ship it, we're using billions of devices every day. So ICU4X is ready to use. It's ready to integrate in your project. When I gave this talk when I gave this talk 5 years ago, it was like, here's this cool new idea. Like, who wants to like help us build this? And now it's like, now we're deployed in some of the biggest operating systems in the world. So we've really come a long way in 5 years. These are just some examples of clients using ICU4X. On the left is Canvas Kit, which is a WebAssembly-based Canvas rendering engine. It's used, for example, in Flutter for rendering apps on the web. Pixel Watch I mentioned earlier. Data centers like to deploy ICU4X at scale to reduce their memory savings. As you'll see a little bit later, building a library that's focused on running on low-resource devices means that when you deploy it in a data center, you also save like ungodly amounts of like CPU compute, and you save like ungodly amounts of money like just by reducing the requirements when you deploy at scale in a data center. There's some more ICU4X clients. Firefox, I mentioned. Chrome, shipping in December. Android, as well as the Rust standard library for error message formatting, as well as others. I've been just these last couple of weeks since we had our last release, the 2.1 release. I've been getting pings from like a lot of different clients who are like, "Hey Shane, we're integrating ICU4X, like, you know," and like it's really been growing a lot, especially in 2025. It's really there's more growth in 2025 than like all the previous years together, which is really exciting for the project. Okay, let's talk about what is ICU4X, and I want to show you some graphs. I love that the screen is so big, so you can kind of read my graphs a little bit. If you can't read the details, you can see the slides later. I'll send you a link, or you can download them from the website. But on the top left here is performance. So datetime formatting, that's something that I've spent a lot of time on in order to really get these numbers that you see here. So on the left side is ICU4C. Which is another internationalization library. If you came to the tutorials yesterday, you learned a little bit about ICU4C. On the far right side is ICU4X 2.0, and this is the performance of taking 100,000 dates and formatting them in the medium style. This is just the raw performance, and you can see how we've really been able to move the needle on formatting on performance of date formatting. This one is memory usage. This one's fun because notice the logarithmic scale. So we've built ICU4X from the ground up to use basically zero memory, zero heap allocations, which is one of the things that improves the performance, but it also means that you can run on low resource devices that don't have a lot of RAM. Yeah, this has been foundational with how ICU4X has been designed. This is binary size. The way that ICU4X is designed, it means that we build into your program only the things that you use. You pay for what you use and not for what you don't use. And because of this, we're able to achieve much smaller binary size. This is ICU4X. This is just ICU4X 1.5 was already very strong a binary size, and 2.0 made it even better. If you want to compare to ICU4C, this is the ICU4C comparison. It's just a little bit hard to compare. I swear that I tried my best to make this an apples-to-apples comparison. It's hard when you're comparing libraries, but I really tried to make this an apples-to-apples comparison. I even contributed code to ICU4C to try to make this to try to make the ICU4C number as small as I could in this comparison. And one of the main messages from this slide is that these results were only possible by starting in a clean slate, building from scratch with these goals in mind, learning from what ICU4C has done over 20 years in order to really get these results that you see here. So another thing that sometimes when I talk about ICU4X, I'm surprised that people don't realize because I just take it for granted, but I'll remind people, because that's what this presentation is for, is that ICU4X works in many programming languages. I haven't used the word, I think I used the word Rust once earlier in this presentation. A lot of people say, oh, ICU4X, they're rewriting ICU in Rust. Like, I really don't like that definition of ICU4X, right? ICU4X is a lightweight, portable, and secure I810N library. The fact that it's written in Rust is a technical detail that you're not supposed to worry about, because you can use it from C++. So we have C++ bindings for ICU4X. You write your C++ app. We have C++ headers that you can link to, and those link to the ICU4X C ABI, which means that you can swap it in as a DLL. Just like you can libicu, you can swap in the ICU4X DLL and just use it just like you would use ICU4C. We also support Flutter through a similar thing. Flutter apps through native bindings can also use ICU4X. We even support JavaScript on the web. Using WebAssembly, you can use ICU4X. So try to forget the definition ICU4X is an ICU ported to Rust, because that's really just not accurate, because although we chose Rust as a programming language that is able to serve these goals, really what we're trying to do is bring internationalization to where you are, to where your environment is. We're trying to bring ICU4X to that environment. Just like sometimes how I say, people ask me, like, what makes you excited about I810N? It's about bringing software to the user where they are, right? ICU4X is about bringing internationalization to the programmer where they are. So yeah, ICU4X in many programming languages. Cool. Now that I've done the intro slides, I'm going to go ahead and move on to the new content. So this is what you all came here for. You may have seen the title of this talk. It's ICU4X in Android and Chrome, right? Let's go ahead and talk about this a little bit. So Android, how does Android use ICU4X? So ICU4X is currently lives in the Android C library, which is kind of funny. We're implementing a C library using Rust, which is kind of an interesting little quirk there. they used the ICU4X case mapper. This landed in the Android open source project in Q1 of this year. The Android C library can be called by third-party Android apps. It can also be used by, it's also used by the operating system itself. One of the things that Android was able to achieve by using ICU4X to do their to solve their internationalization needs is that they were able to simplify their build process by doing static linking. So I'll go a little bit into the technical details here. This is called the technology workshop, so I can talk a little bit about tech, right? So there's two main ways that you link to libraries that you're trying to use in your program. One is called dynamic linking. And this means that you build your program, and then the library that your program uses also has to be available at runtime when you're running your program. So you ship your program, and then separately you ship a library. That's called dynamic linking. Static linking means that you build all your dependencies into your program when you build your program. So you might be familiar with this if you've done any type of programming. You're familiar with, like, if you have dependencies, like, do you resolve them basically at compile time or at runtime? There's pros and cons to these approaches, but what Android was able to do was they were able to take ICU4C, which is a 2 megabyte, 5 if you add both of them together, to dynamically linked library, and they were able to take ICU4X and statically link it directly into the Android C library, which was just 82 kilobytes. So they're able to, they don't have to ship these, or at least they don't have to link to these large DLLs anymore. Now they can actually build and do the compile time linking of ICU4X into their program, which simplifies their build process. ICU4X's modular design enabled them to do this. Chrome. So let's talk a little bit about Chrome. So inside Chrome is this component called V8. It's the JavaScript engine that runs inside Chrome. JavaScript apps use the Chrome JavaScript engine through any type of binding, but I'm going to talk today about the Temporal API. So Temporal is the new JavaScript date and time API. I've been involved in the evolution of the Temporal standard in TC39, so that you can now have actually good date and time types when you're writing JavaScript code instead of just the regular old-fashioned date type that doesn't even support time zones properly. So we have this all new date time library in JavaScript. But how does Chrome implement it? Chrome implements it using this library called Temporal RS, which is Temporal written in Rust. And Temporal RS uses surprise ICU4X in order to do its non-Gregorian calendar calculations. So this is how ICU4X is currently integrated into Chrome. It powers the Temporal API, which is the new date and time libraries that you can use in JavaScript. This is shipping in December, by the way. So you'll be able to actually use this in Chrome and know that ICU4X is working under the hood. Another thing I want to highlight about this integration with Temporal and ICU4X into Chrome is that Chrome had been shipping the ICU4C time zone database for many years. And we didn't want to have to ship another time zone database in order to support Temporal, in order to support ICU4X. So ICU4X is actually able to read the time zone database from ICU4C in order to implement the Temporal specification. And this improves the integration because we can do sort of one piece at a time. We can use ICU4X for Temporal while still using ICU4C for other components that have been using it for a very long time. So for people who are trying to integrate ICU4X into their systems, they would appreciate something like this because it shows that you can do sort of one step at a time. So Chrome ease of integration. These are some of the wins that we were able to deliver to Chrome. One was because we were able to, because ICU4X was designed with supporting the modern Temporal way of doing dates and times. Chrome didn't have to reinvent this. They could leverage ICU4X and Temporal RS to do this calculation so that they didn't have to do it themselves. So we were able to reduce the number of lines of code that the Chrome team needs to maintain moving forward. So just as an example, SpiderMonkey, which is Firefox, implemented Temporal in straight up in Firefox, and that was about 30,000 lines of code. In VA to support Temporal, it takes only 10,000 lines of code because so much of the logic lives in these third-party libraries, which is much easier for maintenance and for integration. The other thing I already mentioned, the ICU4Z time zone database is still being used, so we don't have to ship duplicate time zone data. So these are just some lessons learned from integration with Chrome and Android. One was that the Rust integration was smooth. Again, a lot of people are like, "Ooh, Rust is scary." I don't exactly know why people say that, because we had quite a good experience with integrating Rust into these code bases, with integrating ICU4X into these code bases. It largely is transparent with both Android and Chrome have a lot of C++ in them. They're C++ primarily in their code base. We're able to integrate transparently into those code bases. Diplomat generated bindings. Diplomat is the tool that we use for generating the cross-language bindings. On the slide where I had that flowchart of different programming languages, that's Diplomat. Diplomat generated bindings makes ICU4X easy to use and be efficient from C++ and other languages. This third bullet point is an interesting one. So we implemented a fuzzer in Chrome in order to fuzz the ICU4X temporal and datetime code. And when you run fuzzers, usually what I think of when I think of a fuzzer is I think of like, oh, it's going to find seg faults. It's going to find like illegal memory accesses. It's going to find undefined behavior. That's when I think of fuzzer, I think of it finding those types of problems. With ICU4X, it didn't find those problems. It did find a couple of test failures that we were able to fix by like fixing a line of code in the code base, and now those are passing. That's what the fuzzer was able to find, which is kind of cool. That the fuzzer, instead of like finding security issues, finds actual logic issues. It doesn't have to spend time trying to debug seg faults and undefined behavior. The last thing is that the code size promises are realizable even in these complex code bases. Those charts I showed you earlier about code size, like those are like micro benchmarks. You don't have to believe me that these graphs like are realized when you actually go into production, but this is data that they actually do help a lot. Like these promises that we make, it's not just Shane having a slide that has these pretty graphs on it. It actually works in really complex code bases too. So those are some lessons learned. Cool. The next section of my presentation, I'm going to talk about what's new in ICU4X. We just had a 2.1 release a couple of weeks ago, and I'm going to tell you about some of the new features there. But first, I'm going to talk about structured preferences. This actually came out in the 2.0 release, which happened earlier this year in May. Structured preferences is this new feature we have in ICU4X. It enables resolution between locales and regional preferences from a variety of sources, as well as ergonomic hooking into the host environment. So what this means is when you use locales, most programs are written with locales. ICU4X likes locales too, works with locales. But oftentimes you want to be able to source the locales from multiple different places, maybe from the host, maybe from user settings, right? And you want to be able to do this in a type-safe way. What you could do is take all the different sources, convert them all to locale strings, and then use a locale resolver to like resolve all the different preferences and regions into a new locale string. That's fine, but what ICU4X does is it supports a type-safe structured way of doing that. So we call this preferences. So for example, I have a locale here, ENUS with the hour 12 hour cycle, and then I have and then I create a preference bag. And I use this on this last line here, combine prefs. I actually take the locale and I take this programmatic preferences and I merge them into one, which I then use to create my datetime formatter. So that's what the code example is doing. It's showing how you can take structured user preferences and merge them in different ways in order to be able to create a formatter that reflects all of the different needs. We have some new experimental features. So when I say experimental, what I mean is that we have a lot of contributors. We have a lot of third-party contributors. We have a lot of people who've come into the ICU4X project wanting to sort of help out with internationalization, learn how to code, and be introduced to the field. And they work on a lot of these new features, like duration formatting, for example. This was contributed by a contributor last summer who contributed code in order to do duration formatting. That's like 5 minutes and 3 seconds. That's a duration, and that's a duration format. So this was contributed by someone just like you, a third-party contributor. Unit formatting is how you do, as you might expect, 5 feet and 7 inches, for example. That's unit formatting. Also, localized unit formatting in terms of resolving locale preferences, so you can display road lengths in kilometers or miles or whatever other unit of measurement you might need. Unit formatting. Date from fields. This is it's currently it says experimental, but we're actually using it in Chrome. So Chrome is using a little bit of it's almost done. But date from fields allows you to throw different types of fields when creating a date. So for example, you can throw an era and an era year as well as a month code. Or you maybe instead of a month code, you have an ordinal month, depending on where you get your months from. So you can, it allows you to source your years, months, and days in different types of formats and then be able to merge them together into a well-defined date. Another thing is experimental is host info. So if you use IC4X, we're able to read directly from the operating system. If you have an operating system preference, we have code now that's able to ingest that directly and then create you a preference object that you can then use to create IC4X formatters. There's also been a lot of upgrades to existing components in the IC4X 2.0 and 2.1 releases. One example is redesigned time and time zone APIs. My colleague Robert Sebastian did a lot of work here. There's so many problems with time zones that we've had talks at this conference before about all the problems with time zones. We've done a lot of work in order to make progress on making time zones and time zone display names work properly, work the way that users expect them to work. We've done a lot of work with calendars. A lot of that has been pushed by the Temporal API, non-Gregorian calendars. We've done a lot of work in the Hijri calendar, for example, a lot of work in the Chinese calendar, the Chinese lunar calendar, in order to make them more efficient as well as more reproducible, have actual proper definitions for them. Semantic datetime skeletons. I talked a little bit about this at the talk last year. At that point, it was experimental, and now it's shipped in IC4X. This allows faster and more performant datetime formatting, as well as avoiding cases where you get nonsensical results when you do your datetime formatting, and also the ability to ship smaller data. If you came to the tutorial yesterday, you were able to see how we were able to get a datetime formatter data down to just like a few kilobytes for a single locale, which is just unheard of in other environments. Collation sort keys. This is a feature that a lot of people ask for. So for example, if you're working with a database and you want to store strings in a database and you want to be able to store them in the collation order according to a certain locale or according to the root locale, you want to be able to take a new string and search based on what we call a sort key in order to figure out where it should go in the database relative to other entries in the database. So collation sort keys is now implemented in IC4X. One nice thing about collation sort keys in IC4X is that you can, with your database, you can now ship like this database table was based on this specific Unicode version because IC4X support. If you came yesterday, you learned IC4X supports custom locale data. You can create You can create any API with a specific version of the data, which means that you can do something like, hey, this table was built with this path to the collation data file. And you can actually reproduce these sort keys even like several years in the future, even if Unicode has been updated. You can reproduce the sort keys as they were when you built your table. So this is another really exciting feature that we have now available in IC4X. Normalizer performance optimizations. Processing text is really important. It's important to be performant there. This is things like NFKD. This is things like taking characters with diacritics and to making them either individual, like combined code points or separate code points. Better plural selection. So this is if you're doing message formatting, you have 0, 1, 2, few, many, other. You want to select the correct form of your sentence. IC4X, we did a lot of work there to improve that API. Segmenter locale tailoring. This is a feature that IC4C has had for a while. IC4X has it now too. This allows, for example, certain languages like the one I always like to point to is Finnish, uses the colon character in order to take like loan words from other languages and make them into adjectives, for example, and uses the colon to do that. In most languages, a colon separates a word or a line, but in Finnish, it's actually part of the word. So we support things like this in order to have more proper word and line segmentation. And datetime parsing from RFC 9557. This is a specification that allows you to take a datetime string and get it into code. This datetime string has to obey a certain format. It's the same format used by Temporal. And the core crates are no alloc. What this means is that you can use this in environments like Android where you don't have access to a system allocator. Core components are completely heap allocation free, which is really cool. And there's so much more. You can click this link in the slides later just to see like the full list of the changelog. It goes on for pages because there's really so much work that's been landing in ICU4X. Speaking of work that's been landing in ICU4X, here's some of the people who made that work happen. I had this slide last year. I updated it for this year. Top contributors, Robert Bastian, my colleague in Zurich, is the prolific contributor. He's done 417 commits over 365 days. So you can see how important he is to the project. Manish, who I saw popped into the room, did 213 commits over 365 days, also a very prolific contributor. I'm next on the list with 181 commits. Yunus is another colleague. He did 41 commits. Henri Sivinen did 32. He works at Mozilla and has done a lot of the work on the collator and normalizer. Kevin has done a lot of work on datetime and integration with Temporal. ZB, who gave the talk yesterday, who gave the tutorial yesterday, he's been doing a lot of work on locale preferences and host info. Makoto has done a lot of work on segmentation everything in the text segmentation crate. And there's so many more. I went through the list. I pulled out the top 8 in the other slide, but there's like 35 total here of people who've contributed many different types of components. So Elango, I don't know if he's in the room. He's done a lot of work with Unicode properties, for example. Moritz has done a lot of work with the Dart bindings. Sydney is the one who contributed the collation sort keys. Jose has, we call him Julian. He's contributed a lot of the work also in the temporal and time zone space. There's so many people here, I don't always remember which component they contributed to. Opnub at the bottom of there, his name is Shenghong, and he's done a lot of work also in the text segmentation crate. So many more. I'm not even going to try to name what all these people have contributed, but it's really amazing that we have so many contributors, so many talented people really building up this library. So I think, how much time do I have? We go till 12, I think. We go till 12. I think we have time just to really quickly click this link. Let me bring this over here. Let's see. There it is. Cool. So I'm just going to walk through this demo. I have to sort of look over here to see what I'm doing. So if you go to ICU4X.unicode.org, if you go here to ICU4X.unicode.org, this is our website where you can learn all about ICU4X. You can learn about how to use it. You can read the documentation. You can follow tutorials. I'm going to go ahead and click on this button up here that says Interactive Demo. And what it does is it pulls up this little demo here where you can look at all these different features in ICU4X and play around with them. And this is running in the browser with JavaScript via WebAssembly. So for example, I can do date formatting. So I can do like a date formatter. This one here. I can like put in a locale. Like maybe I want to put in like Chinese, and then I can do a length, alignment, year style, and then I can put in like a date, like 2025, 11. What's today? 11/12. It's today is 11/12. And then I can click this button, and then it'll format the Gregorian calendar with the Chinese locale. And I can change the locale, of course, and see how it looks in different locales. Like maybe I want to put in German or something like that. I can click the button again, and it'll format in German. Well, that's kind of not interesting, because that's the same. Let's try Spanish. I can try Spanish, and it's translated into Spanish and does all the formatting that you would expect to see. It puts the year, month, and day in the correct order, and everything that you would expect an item library to do. So you can load this page later and just go and see all these different things here, all these different features. So many of them: case mapping, BiDi, dates, date times, decimals, properties, locales, plurals, time zones, everything you want. You can play around with this little online demo, which is using ICU4X in your browser, which is really cool too. Cool. Let me go back to the slides, and then we can finish up. Cool. Next step, so this is my last slide. I'll take questions now, but this QR code on the top right goes to the ICU4X announced mailing list, which is where you can keep in touch with new releases, new announcements. We send like maybe 2 or 3 emails a year, which are information packed, just 2 or 3 emails a year. I encourage you to subscribe to that. The bottom right is my social media. On the left here, describes some of the other things. There's our website. We love mentoring new contributors. I highlighted some of the things that contributors have done, third-party contributors. Some examples of things that we're always looking for: adding a new programming language, maybe C# or PHP. If you would like to add ICU4X into those languages, we can help you do that. It's not too hard. We've designed it so that it's something that one person could do, sit down at a computer, take a couple days, and get ICU4X running in PHP. That'll be a very cool contribution to make. Adding new components. I saw Mike in the room. Person names would be a great thing. We'd love to see that finished and rolled out to users so that users can use that feature across all the different programming languages that ICU4X supports. Cool. I've got a few minutes for questions. If anyone would like to ask some questions, please. All right, and who's our mic runner? I think Manish is our mic runner.
Yes.
Cool. State your name and where you come from and your question.
Colin Sprague. And I work for DocuSign. You talked about structured preferences and merging structured preferences. I couldn't tell if you have an API for doing that, or were you just showing the code that makes it possible to do it through?
So the code sample that you saw was ICU4X code using the ICU4X API.
Okay.
So yeah,
so like
there's an API for it.
So okay, cool. Thank you.
Every component. So the way we did it was. So for example, datetime requires a different set of preferences than collator, but then just requires a different set than decimal. So each individual component has a preferences class or struct that then you can use for that specific component.
Hello, I'm Yaniv from Block. Could you speak more about how you said the clients can only pay for what they use? So does that mean like Chrome would choose their locales or choose the components that they need? How does that work?
Great question. So the answer for both those questions is slightly different. So I'll talk about components first. Okay, so when Chrome uses a particular component, it means that they can run their any sort of dead code elimination, tree shaking, if you will. And ICU4X works really well with tree shaking, as you saw with some of those numbers I showed earlier. So that's how we do component-based slicing. For locale-based slicing, we have a tool called ICU4X DataGen, which you can run with the set of locales you want to be able to support. And then it'll build the data into all the features that the program is using. So that's how we solve those 2 problems.
Thank you.
Hey, I'm Navid, and I'm from Amazon. And I've worked with ZB before. We used to work together on devices. So we just released a new operating system, Vega, and we run on ICU4C. And if we had to move to ICU4X, would it be backward compatible, or do you have to be both of them have to be deployed together? And the other question I have is it ABI stable? Because ICU4C had this C++ API stability issue.
Yeah, great question. So the first question was about migration. So the example that I showed earlier about, for example, how ICU4X is able to use ICU4C time zone data is one example of how we're able to make that transition process a little bit simpler. So it's not realistic to like take a very large code base and like have one CL that like changes everything. So we're really looking a lot at ways in order to make that migration easier. It turns out that ICU4X code slices so well that a lot of times you can do that incremental migration and not have a lot of regression in terms of code size. I'm happy to talk to you more about that. We're happy to talk to you more about that because Manish, as well as myself and others, are really focused on how we can solve this problem, make this as easy as we can. The second question was ABI stability, right? So ICU4X has the C ABI. I'm going to go ahead and slide halfway back in the presentation into this slide, just to demonstrate. So we have a specific ABI that sits on top of ICU4X, and this is a C ABI, which means that you can use it as a DLL. And this works, you can upgrade ICU4X versions, and code built on the old ones will work on the new ones. We keep the old ABIs around. We spend a lot of time before we add them to make sure that when we do add them, we're very happy with them, so that we don't have to go back and change them. So it's designed with this in mind, with this exact use case in mind.
Thank you.
I'm Phil from TikTok. I have a question: is that does ICU6 have a feature that can identify, like, for the format string, can identify which part belongs to what? Kind of, instead of making one string, but fragment it into parts and annotate what part it means.
Yeah, that's a good question. So in internationalization, we call that parsing. We call that we call that taking basically a localized string and figuring out what the parts are of that string. The short answer is many of the use cases for this are better served by not doing this in the first place. So for example, a lot of times when people have this feature, it's like, I gave the user a text box to type in a date, and now I need to like parse that date. What you should instead do is give the user a date picker, so that they can actually pick the date and you don't have to do the parsing at all. Now there are sometimes use cases where you want to do this problem. For example, if you're using free-form text, if you're trying to like take semantic meaning out of like a web page you scraped, maybe you want to be able to figure out what the dates are there. ICU4C has this feature in it. It's never worked completely really that well. There's no specification behind it. It's possible that like a narrow subset could be added to ICU4X. We have an issue open for that with certain parameters that we're looking for, but really, like, I would suggest using LLMs that really have better understanding of text in order to do this step. My argument, and again, I have strong opinions on this. Other people might have different opinions. Is that this is not an IE10 library is not the right tool to solve this particular problem, but there are other tools that can solve the problem. So for example, if you use something like a large language model, you can say, please transform this freeform date into an RFC 9557 string, and then ICU4X can parse the 9557 string. So something like that, where you sort of separate the some interpreting what a human tried to mean from like the actual parsing is I think a step that you could do there. But I'm happy to talk for hours about this topic.
Thanks.
Mike?
So in JavaScript implementations, they created format to parts. And did any of that get into ICU4X?
ICU4X supports format to parts, datetime, decimal. We need to because it's required as part of Chrome, as part of the JavaScript engine has the format to parts function. So yes, we support that.
Yeah, maybe explain to some others what format to parts is.
Yeah, so when you format a date, maybe I can give an example of some dates. Back to the slide that has all the examples on it. Yeah, so like this slide here has all these examples. So like this one here, this number and date range formatting, right, has like I guess that's month, day, year. Yeah, month, day, year. So format to parts means that we annotate that the first code point of that string is a month, and that the third code point of that string is a day. We also can annotate that the first 8 code points of the string are the first date in the date range. So we can add these annotations, which is useful, for example, if you want to maybe make the years be bold-faced or something like that. People have different use cases about like doing formatting and display. So yeah, ICU4X supports that feature. Yeah, maybe I'll make you the last question because I know that we're all want to get to lunch. So,
hi, my name is Nitin. I work at PayPal. Could you explain how does this relate to like other libraries like Intel or NextIntel? Does it internally use ICU4C as part of the implementation? And are they like, if it is, then does it have plans to move over to ICU4X?
Yeah. So a lot of the libraries are focus on, for example, like if you use IAT Next, which is like a popular Node.js library, if you use like React Intel, if you use something like Format.js, Globalize.js, each library solves a different piece of the puzzle, right? Like when you're working on localizing your app, you need something that does message formatting. You need something that loads resources from the back end. You need the internationalization components of that. You need a templating engine so you can put it into the layout. You need to do like BiDi stuff with like, so every component solves a different part of the puzzle, right? So ICU4X solves the internationalization and formatting parts, this stuff, right? This is the stuff that ICU4X solves. So a lot of these libraries could maybe use ICU4X as a dependency in order to solve this part of the puzzle. It also depends on the environment because ICU4X is, if you're deploying to the web or if you're deploying to like a mobile device, like you can use the system I8N to solve those problems. Sometimes there's reasons you want to use a library like ICU4X. For example, if you're if you want to have consistent behavior across all devices, then you might want to use ICU4X. But if you want to, for example, have more consistency within the device, you might want to use a system library. So there's different reasons you want to use one versus the other. Yeah, this is the stuff that ICU4X solves. And if you're interested in like, does my library, should it use ICU4X? Then like you can see sort of what part of the stack it fits into. Cool. So that was the last question. I know you're all ready for lunch. So I'm going to be around for the rest of today and tomorrow. Happy to answer more questions. I'm going to fast forward again back to the end so you can get my email again. Also, thank you to the sponsors and everything. You can get my email and subscribe. And it was really great talking to you all, and thank you all for attending.